Hey everybody, Dave here. Today I'm doing more C# practice on exercism.org. Last time I did actually a number of them. That was the first video where things didn't go well and I briefly went over several of the exercises I completed. The last one was perfect numbers. We're still avoiding fourth because I still don't know how to solve that. We're going to come back to it though. Today we're going to be looking at Collat's conjecture. I have no idea what that means. All I know is that this exercise says it's supposed to be easy. And I think after what happened last time, I need something easy. I plan to just do this one exercise today. So I'm going to click into it. We'll talk about it. I'm going to try to solve the solution, submit it, try to get it to pass the test results. I'll talk about how poorly I did, and then that'll be the end of the video. Here we go. Okay, so Collat's conjecture. The instructions say that the Collat's conjecture or 3x plus 1 problem can be summarized as follows. Take any positive integer n. If n is even, divide n by 2 to get n divided by 2. That seems simple enough. If n is odd, multiply n by 3 and add 1 to get 3n plus 1. Repeat the process indefinitely. The conjecture states that no matter which number you start with, you will always reach 1 eventually. This makes me wonder if I've watched magic tricks that involve this, and this is actually just the formula they were using. Given a number n, return the number of steps required to reach 1. Okay, the example they give us is that if we started with 12, then the steps would be as follows. We'd go from 12, doing whichever of the two paths that they talked about. You'd get to 6, then 3, then 10, then 5, etc., until eventually on the 10th step you'd reach 1, and then it results in 9 steps for input n equals 12, then the return value would be 9. Okay, so let's go ahead and go into the editor. I love that I get to develop in a browser. That makes things so much simpler. I do have Visual Studio and I don't mind creating new projects, but it's a little bit cumbersome when I'm doing really simple problems like this. So we just have one method called steps. It takes an input of an integer called number, and then it returns an integer. So I think that this is going to be pretty easy because, like I said last time, my thing is loops, and I can't seem to do anything without loops. If it involves link or anything like that, my brain just immediately is just like, well, why don't I just do a loop instead? Okay, so what we're going to do is let's attack one of these first. So I guess I can do kind of an if statement. So if this actually says if n is even, then divide n by 2. So maybe what we'll do is create int n equals number, and then that way we set the input into a local variable. And then I'll do an if statement. So if n is even, so we need to go if n mod 2 equals 0, then we need to divide n by 2. So we'll do it like this, n equals n divided by 2. And then the other one is if n is odd, so I guess we'll do an else. So else multiply n by 3. N equals n multiplied by 3, and then we got to add 1. So let's do this to make it clear. Okay, add 1, and then we set it back into n. And it says we need to repeat the process indefinitely. So I assume that I can just do a while loop here. So we'll put while. Maybe it's supposed to be a do while loop. We'll see. While n is not equal to 1. Then we want to loop. Let's grab everything that I just created, put it inside the while loop. I think I actually need to put this part outside the while loop because we need our integer to exist beforehand. And then after the while loop is done, we will return. Oh, we got it. We actually have to track the number of times this takes, right? So let's go int steps equals 0. If we go in here and do anything, then we should probably increment steps right at the start. So we'll just do this. I guess it doesn't matter. We can do it at the end. Okay. So steps plus plus will increment steps every time we loop. And then at the end here, whenever we get out of the while loop, we will return steps. Okay, so I have a really terrible problem with trying to rely on the compiler to tell me what my problems are. And I'm going to try not to do that here. So we are taking in a number and we are setting the number into n here so that we can change it. And we are keeping track of the number of steps, the number of times that we have to interact with or do something to it. We're doing a while loop to effectively loop forever until n equals 1. So while n does not equal 1, let's say for a second that this is 0. What happens? 0 comes in here. I think that 0 goes in. 0 is not equal to 1. It will do 0 mod 2. I think that's 0. And then so it will go 0 or n equals 0 divided by 2, which is not dividing by 0, right? But it will equal 0, which means that it will always equal 0. Let's see if the test cases, okay, 0 steps for 1. Does it ever provide 0? Okay, 0. Okay, there we go. There's our answer. Argument out of range exception is what I'm supposed to throw if the input is a 0. So we'll just do like if number is equal to 0, then throw new argument out of range exception. And we call it good for now. Okay, and then if it's, let's say it's like 5, then it will go 5 is not equal to 1. It'll go into the, it'll say, is 5 mod 2 equal to 0? It shouldn't be, so it should go down here. N will equal 5 times 3, which is 15, plus 1, which is 16. And then it'll keep going around until eventually it equals 1. Let's see if 12 is correct. So if 12 comes in here, 12 will, it's not equal to 1. If 12 mod 2 is equal to 0, it is. So n equals 12 divided by 2 is 6. Okay, so it looks like we're going on the right track. So let's go ahead and test this because I think that this is all it takes. This is not looking good. Uh-oh. We did something wrong. Okay. Yeah, you can go ahead and finish now. Estimated time, running time, 4 seconds. Your test timed out. This might mean there was an issue in our infrastructure. More likely, it's just your code is running slowly. That's fair. Infinite loop, most likely. Fair. Let's go see where the problem is. So while n is not equal to 1, we should have, if it did actually eventually get set to 1, then it would get to the end of the loop. It would evaluate that n is equal to 1, and it would break out and it would return steps wherever we are at that point. So somewhere, we're just missing something small. That should have worked. What I'm guessing is that one of the other test cases is causing the issue. So I'm going to go look at those. So 0 steps for 1. Because it already equals 1. I would think that that's actually succeeding because steps is equal to 0 already. Divide if even. Okay, I think that's fine. Give it 16, give it 12, that's fine. Large number of even and odd steps. Okay, what might be going on here is that this logic is actually correct. And the whole point is that I am not doing it efficiently enough. There must be something I can do to sort of skip a bunch of the steps. So let's think about, I'm going to think about that for a minute here and come back to you with an update. Okay, so here's the thing though. I was thinking, oh, maybe there's a way you can skip steps. And maybe that's true, but if I skip the steps, how would I know how many steps it was supposed to take? So if there's some way to skip them, I need to also be able to guess how many it would have been. And at the moment, I have no idea how that is supposed to take place. Okay, so here's another thing I just came across. This says if it's a negative value, it's an error. I just assumed that this wasn't, oh my goodness. It says right here, take any positive integer in. Oh my gosh. Okay, so let's go up and change this. Where if number is equal to 0, we'll change this to if number is less than or equal to 0 so that even negative numbers get thrown as an argument out of range exception. And I suspect that may be what was causing our infinite loop because I just missed that it has to be a positive integer. So if it's negative, maybe it can never reach a result of 1. So let's run it now and see if that fixes the problem. That was it. Okay, so look, I think what we've learned this time is that it's important to read carefully when instructions are given to you. Now, granted, instructions will not always be given correctly, or they may not be worded properly, but there's a good chance, especially in a situation like this, where hundreds, if not thousands of other people have done this same kind of exercise, that the instructions it gives are probably good and they're probably correct by now. If I had just noticed that it said positive integer, we might, no, I don't think we could have gotten it successful on the first try, because I don't think it would have occurred to me that 0 is not a positive integer. I mean, of course it's not, but I think it wouldn't have occurred to me. So I think I would have failed on the first one, and then I would have changed it to be like not just less than 0 here, but also less than or equal to 0, and then everything would have worked. So this is pretty simple, but I think this might be the first time that, for a little while now at least, that I've done an exercise in this website where the way that I went about it was probably the correct way, specifically because you were supposed to track how many steps it takes to reach the results. And that told me I wasn't supposed to come up with some special method of handling it, because you can't skip the steps. That's sort of the point. So I think I'm going to go ahead and call it good on this video today, because I think that was successful. When I make multiple mistakes, correct them, and then learn from it, like, that's a successful video. And if I go to the next exercise, there's a chance that I could double the number of mistakes in a single video, and I don't think we should chance that. I almost forgot the most important part whenever I do these exercises live while recording, is that at the end, I get to click submit and then click continue without waiting. I don't know what that does, but it excites me every time. And then you see this processing. I like to come down here and I like to click mark complete before that's done too. So looks like we've completed Collat's conjecture, and we I progressed in 3 concepts: if statements, numbers, and while loops. So thanks for watching, and I'll see you next time in my next C# video, where I make a fool of myself making simple mistakes like not being able to read.